Hi, this is Durga Charan, working as an assistant professor, Department of CSE, and today we would like to discuss about introduction to Internet of Things. Before going to this topic, we would like to discuss what the prerequisites for this subject. Especially, we need a knowledge on computer networking and how the devices are communicating each other. Then, after learning outcomes, after completing this topic, we will understand what are the explorable informations regards the history of Internet of Things and learn the application of IoT. Then we would like to go with the flow. First, we would like to discuss history, applications, trends and characteristics, enabling technologies, and criticism, problems and controversies, adoption barriers. We will discuss all these things. Now we would like to go for the history. Internet of Things describes a device with sensors, especially processing ability, software, and other technologies that connect and exchange data with other devices and systems over the internet or other communication networks. Let it be if we are designing a computer and it wants to communicate with some other user defined sensors, or we would like to acquire the data from the sensors, then the time it goes to be the communication or the collection or the exchange between the devices. Let it be the Internet of Things encompasses, especially it involves with the electronics, communication, and computer science engineering. Especially it deals with the electronics and computer sciences. Why we would like to point out it? The electronics, such as embedded systems or any communication devices, it is to be communicating with the computers. Earlier, if you would like to make any devices with electronics, we can simply use transistors, any other basic electrical and electronic devices. But nowadays, if we are going with the Internet of Things, everything will be communicated with the computers. If we are purchasing a cell phone, if you would like to identify what happened with the computer, we will identify with the communication with the computer. Computer can grab whatever the information it receives and whatever the data processor have done will be automatically uploaded to the computer. So the communication, whatever the information that receives from the sensors or any node or any device, it will be transferred to a computer. If we are going with the consideration of misnomer, especially this IoT is not completely communicated to the internet, whatever the devices that connected to the internet. But nowadays, if we are establishing a local network, so the devices will work with the local network, not only with the internet. If you are communicating any device through a network, it is to be user defined, or if it is to be in our hand, we can go with it. Basically, this IoT is an encompasses of all the electronics and communication and computer science engineering, and it deals with the communication of the devices across the network. Now we would like to discuss about of the fields. What will be the introduction of the IoT? The field has evolved due to the convergence of multiple technologies, including ubiquitous computing, community sensors, increasing powerful embedded systems. Nowadays, we are going with the machine learning, deep learning. Yes, it leads with the all these technologies. It is converged and multiple technologies. Ubiquitous means it is to be existed everywhere. Commodity sensors, especially when we would like to grab some information. Earlier, our laptops doesn't supports with the SIM cards. Now, if you would like to identify the new technological laptops, whatever the next generation laptops, it supports with the SIM cards. Earlier, it doesn't exist with the 6G. Now, it is common for all our cell phones. If you are looking to a new network, it will provide 4G, 5G, and 6G also. So day by day, the sensors and the transformation and the increasing of power embedded systems is it, it is more in the current market. So if you'd like to process any data, we need a well established learning missions. Let it be machine learning. We have to train the system. If it is to be trained by itself, or if you go to the deep learning, or if in future we may not predict what will be the next technology it may be. So everything will be included in IoT because it encompasses computer sciences as well as electronics. Older fields of embedded systems, we are saying it is to be older because nowadays, if you are using Raspberry Pi or Arduino or BeagleBone, this technologies enables the internet connection. If you would like to blink a light for 10 times, you can write a C program. You can dump that program into the chip. If you would like to write a Python program, you can use Raspberry Pi. Using that Raspberry Pi, you can write a program, Python program, to blink that light for 10 times or 20 times, depends upon the user requirements. You can write that program and you can dump it into the chip. The chip, especially if you go to the Raspberry Pi, it is having an operating system. Later on time, it will go to the application. That application works with the Python program. Whatever the logic that you have written already, that will work on in it. If you go to the control systems, especially automation, including home and building automations, these fields independently and collectively enable the Internet of Things. If we are using a laptop, we would like to exchange the information from your laptop to the another laptop. You need a network, whether it is to Bluetooth, infrared, Wi-Fi, WiMAX. If you are going with the Cat5 LAN cable, if you go with the Ethernet cord also, you can exchange it. Earlier, we are having desktops. That desktop doesn't have the Wi-Fi. Later on time, we are inserting the chip into the motherboard of that desktop. It is enabling with the Wi-Fi. Similarly, whatever the technology it may be, we can use those technologies we, to the Internet of Things. The main concept of the network of smart devices was discussed earlier as 1982 with the modified Coca-Cola vending machine at the CMU University, especially the first ARPANET connected appliance, able to report its inventory and where newly loaded drinks were cold or not. They are sensing that information and forwarding this information to the systems. If you go to the Mark Weiser's in 1991 paper on ubiquitous computing, the computer of the 21st century, as well as academic venues such as UBQ computing or pre-computing, produced the contemporary vision of the IoT, but not directly the IoT. Ubiquitous means it is to be everywhere. So the production of those computers, especially to make the computing many way, many ways, such as ubiquitous. Here we would like to understand the term Internet of Things was coined independently by Kevin Ashton. He is the Procter and Gamble P&G company, worked as a manager. Later of MITS Auto ID Center in 1999, though he prefers the phrase, especially the term Internet of Things. At the point, he viewed radio frequency identification, that's what we call it as to be RFID in general, as essential to the Internet of Things, which would allow computers to manage all individual things. The main theme of the Internet of Things is to embed short range mobile trans- transceivers in various gadgets and daily necessities to enable new forms of communication between people to the things and between themselves, especially things. If you are wearing a gadget, that gadget wants to alert you at some particular time. You have to program it. If it is having a operatable thing, let it be your smartwatch. You can get contact with the phone also. You can get the information if you are exchanging an information on a social media, such as social networking. If you go with it, WhatsApp or Facebook or any messenger, if you want to check that message, simply your wearable watch can show that information. It can exchange the information between the node, that cell phone, to your wearable device. Now we would like to define the internet of things. It is as simply as the point in time when more things or objects were connected to the internet than people. Initially, Cisco system estimated that the IoT was born between 2008 and 2009. If we would like to identify the applications of this IoT, the extensive set of applications for IoT devices is often divided into consumer, commercial, industrial. If you go with it, such as infrastructure spaces. Now we would like to discuss how it will be useful, how the application of IoT with respect to the consumers. If you are looking to the home automation, in a well-established home, we are having appliance. If you would like to switch on a TV, simply when the user opens the door, it is automatically identify the user in the house. It will switch on the fan automatically. It will switch on the light automatically, and it will reports it on the dashboard. So the home automation, it will be done with this IoT. This electronic communication, especially this embedded devices, makes the communication among the devices, and it transfers the information to the user. In such a way, the consumers will use wearable technologies such as digital jewelries, smartwatches, and so on. If we are using it in a healthcare system, such as connected health, it can record the heartbeat, it can record the O2 levels. So, the appliance with the remote monitoring capabilities, it can transfer the information to the hospital directly also. In such a way, the consumers use this IoT in their day to day life. If you are going with the commercialization, the medical and healthcare, transportation, V2X, especially that V2X communication said that the vehicle to everything. If you are using a car, if you would like to make a communication from your car to your house owner or for your family, it will make the call. If you would like to send an information, simply you can use the cell phone. In similar way, your car will do that. The medical and healthcare, it is to be essential nowadays. Even in a hospital also, we would like to enable this IoT. It is to be commercializable. If you are going with the transportation, if your vehicle passing through so and so location, it is to alert the user. Yes, this IoT will be helpful there. If the GPS is enabled earlier, it can record it onto a server simply. But nowadays, if the IoT is enabled with that system, it can report it into the owner of that bike or vehicle. If you are going with the industrial applications such as manufacturing, agriculture, metropolitan scale developments, energy management, environmental monitoring, living lab, such as the recent networking labs, internet of battlefield things such as product digitalizations, it is to be helpful in industrial. IoT application will be in these fields. These are to be considered as to be industrial. If you are going with the trends, what are the trends and characteristics of the IoT? The IoT major significant trend in recent years is the explosive growth of devices connected and controlled via the internet. Not only with the internet, any network, the user defined network especially. Earlier we are using Ethernet. Nowadays we are using Wi-Fi. Not only Wi-Fi, we are going with many communication networks. The wide range of applications for IoT technology mean that the specifications, especially specifics, can be very different from one device to the next, but there are basic characteristics shared by most. The IoT creates opportunities for more direct integration of the physical world into the computer based system. Let it be a simulation or emulation, then the time we need some sensations. That sensible data will be recorded also. It resulting in efficiency improvement, economic benefits, and reduced human exertions. Especially whatever the hard work that we are doing to do some work, this IoT will help us to make the work easier. In other sense, we can also call it as to be a smart worker. If you would like to do a smart work, the device, whatever the components that we are using, we must need the IoT enabled device. Then if you go to the characteristics, especially intelligence, nowadays we are working on artificial intelligence. In nearby future, artificial intelligence will also change its form to generalized intelligence. Artificial generalized intelligence. So this IoT is enabled with the updated technology, and we can this IoT can accept the new technology also. Let me discuss how. IoT intelligence can be offered at three levels. First, IoT device is it is to be communicating to the device. Second one, whether it is to be edge or fog nodes, whatever the individual devices that it is to be embedded for so and so work, and cloud computing. These three levels are helpful and understandable sensing data to the device. Then go for the architecture. The IoT system architecture, it is simplistic view consisting of three tiers. Tier 1 devices, tier 2 the edge gateways, that's what we earlier discussed, fog or edge computing nodes. Here we are discussing with architecture. So this tier 2 having gateways to communicate. Third tier is the cloud, wherever we are storing, especially this cloud is for storing, infrastructure management, and many uses are to be there. The devices include networked things, such as if you would like to store a data, you can go to the drive. On that drive, you can store the information. If you would like to make some computations, you can exchange this data from this processors. So if you don't have the RAM, sufficient RAM to do your work on your system, you can assign this work to the cloud applications. Cloud application will exchange that information and it can process it, such as the sensors and actuators found in IoT equipment, practically those that use protocols such as Modbus, Bluetooth, Zigbee, different type of protocols are to be there to connect to edge gateway. Majorly, it involves with network architecture, decentralized IoT. If you are thinking about of this complexity, the third character of IoT as a practical approach, not all elements on the Internet of Things run in a global public space. Subsystems are often implemented to migrate the risk of privacy, control, and reliability. For example, domestic robots, especially domotics, running inside a smart home might only share data within and be available via local network. If you are looking for the next character, size consideration, IoT intelligence can be offered at three levels: IoT devices, edge, and nodes, as visually with the cloud computing. If you are going with space considerations, the exact scale of Internet of Things is not yet defined. It is to be unknown. with quotes of billions or trillions, often quoted at the beginning of IoT articles. In 2015, there were 83 million smart devices in the peop- people's house, but now it became 1,000 millions. More than that, also billions of devices that are connected to the internet. Nowadays, we are using many social networkings, such as Social Internet of Things (SIoT) is a new kind of IoT that focuses the importance of social interaction and relationship between IoT devices. If you are looking with the industrial IoT revolution, industrial revolution is to be point O, it is to be with mechanical. Second, if we are looking for the industrial revolution 4, there we are using artificial intelligence. So whatever the application it may be, whatever the requirement it may be, the IoT can support easily. If you are going with a social internet of things is a new kind. If we are going with the enabling technologies, there are many technologies that enable the IoT, crucial to the field as the network used to communicate between devices of an IoT installation. A role that several wireless or wired technologies may fulfill. If you are checking for those enabling technologies, first one it is to be addressability. The objects having an IP address or URI, uniform resource identity. The objects themselves do not converse, but they may not usable. Let it be now be referred to by any other agents, such as powerful centralized servers acting for the human owners. They are working for it. Whatever the device it may be, it requires an identity. Similarly, IoT enabled devices such as Bluetooth connection or Wi Fi connection, as it is having MAC ID, the device, the IoT device, the enabled one, it must need addressability. Second one, it is to be application layer, an application layer protocol and supporting framework for implementing IoT applications. The enabling technology going with the short, medium, and long range wireless communications. If you go with the short range, let it be Bluetooth or mesh network. Wi-Fi, light fidelity, especially it's a updated technology. Earlier we are working with the Wi-Fi. If you are going with a near field communication NFC or radio frequency identification RFID, you have already seen it is its uses in industry. Wi-Fi, what we are currently using the technology based on the IEEE standard 802.11 standard, Zigbee and Z-Wave. These are to be the short range wireless connections. If you are looking for the medium range wireless, LTE advanced, 5G wireless networks, and long range and dash 7 technologies. If you are looking to the long range wireless, low power wide area networking, LPWAN, and very small aperture terminal, VSAT. These are to be the long range wireless communications. If you are looking to the wide Ethernet connection, we have already communicating and power line communications. Earlier, power line communications will transform power as well as signal also. If you are looking to criticism and problems and controversies, first one, platform fragmentations. Let it be the fragmentation here go with the Android or some other operating systems. It is having compatibility. If you look into the JPEG file, it is to be compatible with all those devices. Similarly, the fragmentation of the platform, the IoT suffers from platform fragmentation, lack of interoperability. If you are going with the Arduino, it doesn't require the operating system. Simply, whatever the program that you dump using that Arduino, you can dump it into a chip. But if you are going with a Raspberry, it requires an operating system. That operating system is Raspberry Pi. On that, you have to write the program on Python IDE. So here it is to be the platform fragmentation is clear. And the interoperability, the operability with the Raspberry Pi and Arduino is different. And common technical standards, a situation where the variety of IoT devices in terms of both hardware variations as well as the difference in the software running on them makes the task of developing application that work consistently between different inconsistent technology ecosystems hard. Second one, privacy, unidentifiable connections, and controllability. This is also under criticism. The problem here it is privacy is to be manageable, but autonomy, who is communicating without ID, they may not make the communication. Let it be if you are going with a cell phone, you will get a call through through defined number, phone number. But if the number is not to be known, we call it as to be unknown number. So the device sensor, it can also represents an information to your system remotely. So you may not predict that system is to be defined by you. The concerns about privacy have led many to consider the possibility that the big data infrastructures such as Internet of Things and data mining are inherently incompatible with privacy. Security is the biggest concern in adopting Internet of Things, especially these technologies what we are using currently. It is having a security issues with concern that rapid development is happening without appropriate consideration of the profound security challenge involved. If you are looking with the adoption of barriers here, consumers may be concerned about the product's reliability, effectiveness, or potential drawbacks. Let it be lack of interoperability and unclear value propositions. We may not use a device correctly. If your cell phone is having multiple applications, if you are not using it, it is also lack of interoperability. The privacy and security concerns, especially this is the basic barrier to adopt that IoT. Traditional governance structure. We have to update the governance structure also. Like internet is combination of private and public. Simply IoT is also the same thing. We need the good governance with the traditional approaches may not enable with the IoT. Business planning and project management. It will be helpful to go with the IoT, but these are to be the barriers to identify those IoT technologies. Thank you.